Hey there, hi there, ho there. Welcome back one last time, Unit 14. This is it. This is the end. That's the good news. Bad news, this is a long one. So, settle in, watch these videos at a nice pace, watch them all. Important stuff. So, energy resources. Last unit was mineral resources. These are energy resources. So these are resources that we mine out of the ground that we somehow get energy from. So let's talk about some energy use. There's going to be a lot of facts and figures and tables and graphs coming your way in this first video. So as far as energy consumption by source for the entire world, oil is the #1 energy source. And that's what we need to create gasoline, a lot of other petroleum products. So oil, #1. Coal, globally, #2. Natural gas, 3. Hydropower, 4. And then you can see nuclear, and then how little solar is. Biofuels is just burning biological stuff, burning trees, logs, and stuff. And then all other renewables get kind of lumped in that pink section. So, so this is the world. As far as the United States goes, just a little bit different. All right, let me flip back and forth here. World, U.S. World, U.S. World, U.S. So you can see we use more oil than percentage-wise than the world, but less coal, a little bit more natural gas as well. Right? More nuclear, less hydro. You can see kind of where wind is, how little solar we use, and then the rest. So again, oil is the dominant one here, gas, and then natural gas, then coal. So again, just looking how we how we stack up against the world. We use more oil. We use less coal, which is a good thing, but we still use a lot of it. We use more natural gas, more nuclear, less hydropower. That's water-driven power. A little bit more wind. On average, less solar than the world. That's kind of unsettling. So that's kind of where we stand. Let me move me again. So looking at the entire world, this is a map that shows MTO. MTO is million tons of oil equivalent. If we think about all the energy we use and what that equivalent would be in oil, we can rank the countries as far as this. Just look at how much energy we use. Since different sources of energy, oil, nuclear power, coal, natural gas, all of those are different sources. But if we just kind of average them out to what their equivalent is in oil and add it all together, so now we're looking at the same number. Again, we can look at countries as far as who uses the most. All right. So the darker the blue, the more energy that we use as far as equivalent to million tons of oil. China is by far the country that uses the most energy. They have the most people. No guessing there. India is the second most populous country, is the second most people in the world, but yet it's third. It's because the United States is second in use of energy. So, yeah. So we use a lot of energy, and more on that in just a second. But you can see from there how quickly it falls off. Russia, Japan, etc., etc., etc. So in the U.S., all right, let's say in China. Let's go with China. So purple is annual energy consumption. This is just measured in something called joules, exajoules. Don't worry about the units. Just the longer the line, the more energy you use. So purple is total energy consumed. The blue is per capita energy consumption, meaning you take all the energy used by a country, divide it by the number of people, and that gives you, on average, how much energy per person, essentially, is being used. And that's measured in gigajoules. So again, don't necessarily worry about the units too much. But China, from what we saw on the previous chart, uses the most energy. But yet, per capita, it's relatively low, per person. Just because, even though they use the most energy, there's so many people that when you divide it out, they actually use relatively low amounts of energy per person. Whereas the United States, we're second in energy use, but per person, we are way past China. We use way more energy on average per person than an individual in China. It almost looks to be about 3 or 4 times more energy per person. So even though we're second in energy, we're very wasteful with that energy, and we use a lot of it. India, again, third on that list. Much more people than the United States, but you can see how small their per capita energy use is. Something interesting to note, a place like Canada, they don't use a lot of energy, but per person, it equates to a whole heck of a lot. Per person, it equates to a whole heck of a lot. So they don't use a lot of energy, but there's also not a lot of people in Canada, so therefore that really drives up the per capita. They have to use a lot of energy, for instance, in the wintertime for heating. So there's two things to think about. Just total amount and then per person. All right, total amount and per person. And so per person is probably the more interesting of the two numbers. That's per capita, per person. You can see United States, Canada, Australia, these more wealthier nations really wasteful in their energy use. Again, just a look here again of, well, this one's actually a little bit different. So United States has 5% of the world's population, yet we use in total 16% of the world's energy. We only have 5% of the population, yet we use 16% of the energy that the world has. Okay, so we use 3 times more the percentage of the energy than the rest of the world per person. That's too much. The European Union currently, European Union, so we're talking all the European countries, France, Germany, Spain, etc. They have 6% of the world's population, but they only use 4.2% of global energy use. So even though they have more people, they actually use less energy, the European Union, due to efficiency, due to saving energy. They're just much more proactive in that front. We are very wasteful, and that's not a good thing in the United States. China, 18% of the world's population. They use 20% of the global energy, so a little bit more than the population, only because they have such a large industrial sector. That's where everything is made, is in China. So, in the United States, it would be better if we could get it closer to 5%, but again, we're very wasteful here. So this is the trend of MTO, total amount of energy oil equivalent used. So just think about this as far as energy used throughout the past 30 years. You can see from 1990 through 2020, in general, the total amount of energy is increasing. Why do you think that is? Why do you think the total amount of energy we use on Earth is increasing? Is something else on Earth increasing? Yeah, people. More, more energy. So the population of Earth in general is growing, therefore we use more energy. But a couple little things to note is kind of these drop-offs. For instance, in 2009, that's when we had that Great Recession, so not a lot of people moving, traveling, so that drop in energy use was due to that. And then also we have this drop from 2019 to 2020. We'd expect to use more energy, but in 2020 the total U.S. energy consumption and the world, but the total U.S. energy consumption decreased by 7.3% from 2019 levels. Do you know why that is? Is there something that occurred in 2020 that caused, in general, the U.S. and the world to use less energy? Meaning going less places, less people working, less energy used. What could have caused that in 2020? I'll give you a hint. It starts with it's an acronym, and it starts with a C and it ends with an OVID, right? Due to COVID, people lost jobs, so less energy use by industrial sectors. People didn't travel as much, didn't use as much oil, not as much energy being used. There you go. Interesting to note. So again, like I said, a lot of facts and figures coming your way. This is the U.S. primary energy consumption by energy source in 2019. So a couple of years back, looking at all the different energy sources that we consumed, this is the kind of percentage, of those. Again, kind of matching up to what we talked about kind of at the start of the video. So petroleum, 37%, natural gas, 32%, coal coming in third, 11%, nuclear 8%, and then renewable energy is only making up about 11% of the energy we consumed, and you can see the breakdown from those. And a lot of those are biomass, biomass, so just burning trees and leaves and other things to generate heat and whatever we need it for. Wind, hydroelectricity, solar. You can see how little solar we utilize in the U.S. It's kind of sad. You know, before we move on, let me give you the first part of the super secret code. It is the number 6. You got me? The number 6. One more time, the number 6. So breaking down those sources of energy, where did they go to? This is, again, 2019, at least for these statistics that I'm looking at. So, again, petroleum was kind of the biggest source. These numbers indicate percentages of where they went to. So petroleum, 70% of that energy went into transportation. Go figure. Natural gas, etc., etc. So in general, about 37% of our energy went into generating electricity. Energy and electricity are two different things. You need energy to generate electricity. All right. So if I have a lump of coal, I can't just shove that into an outlet to create electricity. I have to burn that to generate electricity. More on that later in this unit. So about 37% of all the energy went into generating electricity, leaving the other 75-ish% to go into these different sectors, again, of those transportation being number 1. And residential, using only about 16% of available energy. So, you know, even though the vast majority of things we have in this country are houses and apartments and stuff, you know, you really utilize little to no, very little percentage of electricity. Most of the energy you use goes into transportation, goes into the businesses that create things. So your household use of energy sources, electricity, you know, running your washer and dryer and lights, and that's kind of a smaller percentage. So if we really want to make a dent and use less energy, we really want to look at kind of these things. Anything we do residential would be great, but transportation and industry, how can we lower that percentage? So again, this is now 2020, United States energy consumption by sector in 2020. So again, think about what happened in 2019 versus what happened in 2020, COVID, and some of these numbers kind of changed. So transportation dropped almost 11% from 2019, COVID, less people went places. Industry dropped also, so less factories making stuff. Residential energy consumption went up. More people stayed at home, so used more energy around the house. And then commercial, which includes businesses and schools, that kind of went up, mostly because these other things went down. Historically, looking at U.S. energy consumption, historically and projected values, the blue is the total amount of energy consumption in the U.S. The population of the U.S. is increasing. In general, the population of the U.S. is increasing in general. Therefore, we're using more energy. Again, due to COVID, we had a big drop in population. Per capita energy consumption, so that's kind of per person. So per person, what we're looking at. So over time, from about the 90s till now, it's actually been dropping. So how much energy we use per person is dropping. We're becoming slightly more efficient. So you can see kind of the gap as it's projected into 2050. But then down here we have the renewable energy consumption. So total energy from non-renewable sources, more on that later. The light blue from renewable sources, solar, wind, etc., much less than the total. All right. If we want this country to survive, we need to get this light blue line closer to the dark blue line. If not, there's not going to be much of a U.S. left in 30 years or so. All right, let's pause here. Again, this is a little bit longer unit. So we'll pause here. We'll break this first section up into a couple videos. So when we come back, we'll talk about, well, which energy source is best. I'll see you back here in just a second.